To understand the relationship between a body and the forces acting on it, and its motion in response to these forces, we need to look at Newton's 3 laws of motion. So let's jump right into it. Newton's first law of motion, also called the law of inertia, states that every body persists in a state of being at rest or of moving uniformly straight forward, except insofar as it is compelled to change its state by force impressed. Confused? Simply put, it states that an object remains at rest or in uniform motion in a straight line unless acted upon by an external force. What does this mean? Let's take a football. It is currently in a state of rest unless acted upon by an external force, which is kicking the ball. Now, this football continues to move in a uniform motion in a straight line unless acted upon by an external force again. This external force could be anything from a foot stopping the ball, the gravitational force, or the friction acting on the ball, or a combination of all of them. This is called as inertia. Inertia is the tendency of an object to remain at rest or to move at a constant speed in a straight line. Or it is defined as the resistance of an object to any change in its motion, including a change in direction. There is a place where there is little or no resistance at all, and this is the outer space. With this, we get Newton's second law of motion, which states that the rate of change of momentum is directly proportional to the force applied, and the change in momentum takes place in the direction of the applied force. Now, what does this mean? Let's take a bowling ball moving at a certain speed or with certain momentum. If there is some external force acting on it, in this case, let's say some wind, then we see that the momentum changes and it is directly proportional to the force applied. Now let's look at it mathematically. From the law, we know that force is directly proportional to the change in momentum, hence represented by the equation, where P represents the momentum and the arrow represents that it is a vector property. We know that momentum is mass in motion, or mass into velocity. Since mass is a constant, we can move it out, and we know that change in velocity is nothing but acceleration. Hence, from Newton's second law, we get F equals ma, or force equals mass times acceleration. We also know that when the net forces acting on an object balances out, then the object essentially reaches a state of equilibrium, or rest, where net force is F equals 0. Inversely, this means that when a body is at rest, the net forces acting on it is equal to 0. I'm sure we all have heard of Newton's third law of motion, which states that for every action, there is an equal and opposite reaction. Let's look at an example. Here, we see that as the jellyfish is pushing the water backwards, the water in turn is pushing the jellyfish forward with the same force. Which means that if you have an object A, which is the jellyfish, generating a force Fa in a certain direction, on an object B, which is the water, then B is generating a force Fb, which is equal to Fa, but in opposite direction. That is Newton's third law of motion. I hope with this, we have a better understanding of forces and its effect on objects. Thank you for watching, and if you liked the video, please hit the like button and subscribe to my channel.